Okay, well, we did a bunch of graphing on that last chapter, and we start off this chapter doing a bunch of graphing. I don't think the rest of the chapter there's a ton of graphing. I haven't really looked at every single lesson yet. Well, I have. I've taught it last year, but just can't remember exactly. But at least we do it on this lesson. So here's what we're going to do. We're going to solve. When they say systems, I probably could have written it in there. Systems, we'll put little thing, of equations. We're going to talk a little bit more about that tomorrow. Yes? Wrong book. Well, you better go get the right one. But here's what we're going to do. And you probably did stuff like this in Algebra 1. I don't think we did this in geometry. This is probably not a geometry thing. Now, what if I just gave you that? That looks like an Algebra 1 problem, doesn't it? Yes? Yeah, where you got to solve for it. But there's a little problem with this one. What's the problem with this? What if I told you to solve for x? Do you? That would be an x-intercept. So we're not finding the x-intercept. We're just trying to get x by itself and get it to be a number. Can you get it? No, because you don't know what y is, do you? All right, now if you knew what y is, you could plug it in here and you could solve for x. But just getting x by itself, I'm going to have a y as part of my answer. Agreed? So I got a little issue. So what I'm going to have to do is have another equation. If you have two variables in an equation, you must have two equations. Everybody hear that? I didn't learn that. Well, maybe I was taught it. Maybe I just forgot it. But for some reason, when I was in college, one of my professors said, if you have two variables, you must have two equations to solve for both of those variables. You hear me on that? Okay, so it's a pretty important thing. I don't have two equations. Well, I will in a second. But right now, I can't do anything with this. I got two variables, I only got one equation. What if I had three variables? What if I was solving for like x, y, and z? How many equations would you think I would need? Three equations, exactly right. Everybody with me on that? So as many variables as you have to have that many equations. That's our system of equations, all right? So here's a second equation that they give you. Remember doing anything? A lot of times they'll put a little brace next to it like this. You guys remember doing anything like this? Substitution and, what was the other word? Elimination. Do you remember that? Substitution, elimination. Yeah, it should be a common Algebra 1 topic that you do. All right? If not, it's okay, because that's what I'm going to be teaching you in the next couple days. All right? Today what we're going to do is we're going to solve for x and y, but we're going to do it graphically. We're going to do it by graphing both of these equations. And then you're going to see. The reason they do that, because they want you to understand what does it mean to solve for x and y here. You're trying to find a point of intersection. So this is one line right here. This first one is a line. This one right here is also a line. As long as they're not parallel, they're going to intersect each other. And where is that point of intersection? The point of intersection is this x and that y. And it's the same x and y for this one. Okay? So it's the same x and y that works for this, that works for this one down here. All right, so let me grab a graph. I got one right over here. Just happen to have one. Yes? You will, in order to graph. Well, you don't have to graph it, but I think that's probably the most common way to do it. If you wanted to do x and y intercepts, right, you could graph it that way as well. But let's put it in the slope-intercept form, okay? We use that so much. It's so common. Let's go ahead and do that. So let's take that first one. I'm going to rewrite it. And what I want to do is I want to graph this equation right here. This is what you were tested on the last chapter. Would you agree? I gave you something like this. You had to get y by itself, right? And then you graphed it, right? I forget what number it was, but it was on the test we just took. So let's get y by itself. Well, before I get y by itself, I have to get rid of something. That first thing is the x. So how do I get rid of that x? I subtract it from both sides. So I'm going to go 2y equals, if I subtract it from both sides, remember I'm going to put it out in front. Why did I put it before the 4? Why didn't I just go 4 minus x? That's right, because it's y equals mx plus b. The x goes before the b, right? So that's why I just took this, pushed it over, shoved that in between. Agreed? Same exact thing you did on the test. And then one more thing, and we're ready to graph. What do I do here? Divide by 2. Divide by 2, divide by 2, divide by 2. So let's see what we get. Y equals. Now look, this part right here, I remember one or two people got really confused on this. What does this mean? Negative x over 2. I want to write it so that I have a slope. I got a number in front of the x. What is the same thing as negative? This is a negative 1, isn't it? What's the same thing as negative 1x over 2? That's it. Negative 1/2, and then just put the x. I remember somebody you guys put the x down here on the bottom. The x doesn't go on the bottom. This is out in front. Everybody see that? This is out in front of the x. So I kind of try to put the x in the middle somewhere. Put it on the top, but I try to put it in the middle. Don't put it at the bottom. That's a different value. It's not the same thing. So make it look kind of like that. All right? Does everybody see that? That negative x, it's negative 1 over 2, negative 1 over 2x. All right, what about this? Plus what? 2, 4 divided by 2. Okay, so that's one equation. I'll put it in a little box. We'll graph it in a minute. Because how many equations am I going to graph on here? I'm graphing 2 of them, all right? And then when I graph them, I want to find out where they intersect each other. Everybody follow me what we're doing? And then wherever they intersect, that's the x and the y solution for these equations. All right, so I've got one. Let's do the other one. So I'm going to rewrite that. 2x minus y equals 3. Let's do it a little bit faster. I want to move the 2x over here. I'm going to keep the y, and watch, there's a minus sign before the y, so I keep it there. Move the x over, I subtract a 2x. I like to put it right here, push the 3 over. So all I did right there was just move the 2x over. Now, I almost have y by itself, but not quite. So what do I have to do with that negative? Yeah, divide everything by negative 1, or multiply everything by negative 1. In this situation, it doesn't matter. Dividing by a negative, multiplying by a negative is the same thing. So basically what it does, it just gets rid of the negative. So if I multiply that by a negative 1, I get a positive y. Multiply that by a negative 1, I get a 2x. Multiply this by a negative 1, I get a minus 3. Everybody see that? Okay, so that's old stuff, isn't it? Seems like we're just rehashing what we did. And you're right, we are. We kind of are, except for this next part. This next part is the new part. Not the graphing. We've done the graphing before, but it's where they intersect. That's the key to this lesson today. So let's graph the first one, negative 1/2 x plus 2. Some of you guys are still struggling a little bit on graphing this. We got to get this thing down, all right? This is a real basic thing that you got to know how to do when you're in Algebra 2. So first of all, we look at the plus 2. That's the y-intercept. So we come over here on the y-axis. This is the y-axis. You come up to 2 on the y-axis and you put a point. Again, I was looking at some of the tests and I just was amazed that we didn't get the y-axis or the y-intercept in the right spot. We've talked about this so many times. Okay, so the y-axis or the y-intercept, I'm sorry, is right here at positive 2. What is this? That's the what? It's the slope. So you could look at it a couple ways. Watch. You could look at it as negative 1 over positive 2, or you could look at it as what? Positive 1 over negative 2. Would you agree it's the same thing? Let's plot both of those and just show you it's still going to line up the same way. Xavier, you're watching? Not a good time for a nap. So let's start here. Let's go negative 1. So we go down 1 and we run positive 2 right there. That would have been doing it this way right here. I could also rise positive 1 and run negative 2. Check this out. Start at that y-intercept. Don't start at the origin. Start at the y-intercept and rise positive 1 and run negative 2. Look at that. They all line up, don't they? Everybody see that? And I could connect them. If I wanted, I could put a few more in there. Is that all right? 1, 2, 1, 2, 1, 2. Why am I doing all those? I don't really need it. All I need are 2. 1, 2, 1, 2, 1, 2. Just makes it a little bit more accurate, okay? The further apart they are, when I connect those points on the ends, it just makes that thing a lot more accurate. That's the only reason why I put all those points in there. So I'm going to start from there and go to there. See how they all line up nice and perfect? Now, you're using paper. You might have graph paper, okay? But even if you didn't have graph paper, if all you did was put your x and y axis on your paper, try to put the little numbers in between evenly spaced, because it's really important here. You kind of got away with it a little bit. You could be a little bit sloppy on if I just asked you to graph that one line and that was it. But now what we're trying to do is we're trying to find out where these 2 points or these 2 lines intersect each other. So it's extremely important that we're accurate on our graphs. Okay, go out and get a pack of graph paper. Costs a couple bucks probably, all right? Get a pack, and then you can be super accurate on this stuff. On a quiz or a test, I'll give you the graph, right, like I have. I'll give you a little graph thing like this, and you can be accurate on there too. Use a ruler. Some of you guys, man, I thought I was a little nervous when I draw without a ruler, but some of you guys are all squiggly. Get a ruler, get a straight edge. It doesn't have to be an actual ruler with inches and centimeters and stuff. Just take another piece of paper, fold it in half. Take something with a straight edge, right? You guys carry book bags all the time. Get a little ruler, stick it in there. Pull it out when you're ready to do your homework. When you do a quiz, get the ruler out. Make sure it's nice and straight. It's super important, especially for what we're doing right here. All right, enough talk. Let's do this one. Y equals 2x minus 3. The y-intercept is negative 3. So I go down 1, 2, 3. And the slope is 2, or 2 over what? 1. So I rise 2, run 1. So from the y-intercept, I rise 2, 1, 2. I run positive 1 to the right. There we go. You can do it a couple more times. 2, 1. Let's see. Did I go 2? 1, 2, 1. 1, 2, 1. I'll go down here. Negative 2, negative 1. Negative 2, negative 1. That's good enough. Let's connect them. Yeah, I did start at negative 2. I was looking at this. I was like, wait a minute. I messed something up here. You're absolutely right. There we go. I did put it at 2. I can't count. 1, 2, 3. There we go. Now it's going to work out nice and perfect. So check this out. I'm going to rise 2, run 1. You could just stop there and draw your line. But watch this. If I rise 2, run 1, I know exactly where it intersects. Do you see that? So I know exactly where the intersection is. So really, that's all I need. So I'm just going to connect from here to here. Sometimes it doesn't always intersect exactly at one of those points that we used on the other line. Everybody see where they intersect right there? So let's find out where that point is, because that's our solution. Because what it'll do, it'll say solve by graphing. That's what this thing will say. All right, let's write it down. Solve by graphing. Which means you graph both of the lines, find out where they intersect, and the x and the y are my solutions for this. Okay? So where is that point? 1, 2, 1. So what is my solution? It's 2, 1. Now, I don't really like this. Probably would not mark it wrong, but I want it as an ordered pair. You could probably say x is 2 and y is 1. When we do it algebraically, that's probably what you'll get. And we're going to do it algebraically in the next lesson, okay? And we'll talk about that when we get there. So yes, you could say x equals 2, y equals 1, but this is a better way. Why is that a better way? Because we're finding a point of intersection. It's a point, correct? So we want to find an ordered pair. We always label a point with an ordered pair. So our answer should be an ordered pair. On the test you guys took, you had to find the x and y intercepts, correct? I think only 1 or 2 people actually wrote the x and y intercepts the way I wanted you to write it. How should you write an x-intercept? Like, let's say, right here, that's an x-intercept, isn't it? Where's that point? 1, 2, 3, 4. So you should write the x-intercept as 4, 0. See that? Okay, and this is a y-intercept. What's that point? 2, right? So you would write 0, 2. So this is how you would write an x-intercept. That's how you write a y-intercept. I didn't mark it wrong. Some of you guys just said x equals 4, y equals 2. I gave it to you. It's fine. I'm not going to worry about it that much. But it is a point. All right? You are finding a point, and a point should always be an ordered pair. We good? All right. I know I'm rehashing a lot of stuff that we've said before, but I've noticed on the test, right, that some of it's not sinking in. So I got to repeat it. That's the key to learning. Somebody somewhere sometime said, I don't know who it was, but it's a common phrase that the repetition is the key to learning. Have you ever heard that phrase before? Now you have. Repetition is the key to learning. Doing something over and over and over and over again allows you to learn. That's why math teachers give you homework, all right? Because the more you do, the more you learn, okay? And it's going to sink in. So that's why I keep repeating myself over and over again. All right. Let me copy that for the next one. And that's our answer right there, okay? 2, 1. That is our answer. If you wanted to check it, I'll tell you what, before we go on to the next one, let's just check it for fun. You don't have to. Let's do it in a different color since I got a lot of red and white all over the place. Oops, I went back to red. Let's go to yellow. All right, let's check to see if it works. So this means what? The x should be what? Come on, talk to me. 2, and the y should be 1. All right, let's plug it in and see if it works. Let's try it in the first equation right here. Let's see. If I put a 2 in for the x and a 1 in for the y, let's see if it works. So x is 2 plus 2 times y, or 2 times 1 is what? 2. Does 2 equal 4 like it says right here? It does. So does it check? Yeah. That one checks. Let's check the other equation and see if it works. Put a 2 in for the x. 2 times 2 is 4 minus y, which is 1. Does that equal 3? 4 minus 1 is 3. Yes, it does. It checks. All right, so we can be guaranteed 100% without a shadow of a doubt that that is the answer. Do you have to check them on a test or a quiz? No, but if you got time, some of you guys are turning your tests in super early. All right, if you're turning your test in really early, it means you got time to check your answers. So check your answers. We good? Now, if you're running out of time, you barely have time to finish the test, I get it. You don't really have a lot of time to check your answers, but you should always try to. All right. Let's do this. Let's do another one. So this is pretty easy, isn't it? You think? Yeah, so far. And yeah, this is kind of the same thing. All right, here we go. So we're going to solve by graphing. I'm not going to write that down, but that's what we're doing. So here's our two equations. 2x plus y equals 0. And then I'll do this other one over here. 3x plus 2y equals 2. And we got to solve for x and y. But we're going to do it by graphing. So I got to graph both of these. This one's pretty easy. That's supposed to be a plus. It's weird looking. All right. So get y by itself, subtract a 2x, so y equals negative 2x. We'll graph that in a second. I'll put it in a little box so we know we have to graph it. Let's do this one. Subtract a 3x from both sides. See, it's repetition. This is like the third time we've done this today. Plus 2. Divide both sides by 2. By 2. By 2. Y equals negative 3 halves x. Plus 2 over 2 is 1. So we are going to graph that. All right, let's graph them both. I'm going a little faster on this one because we've already done something almost identical to this. So negative 2x. How do I graph y equals negative 2x? Well, what's the y-intercept to this one? It's plus what? 0. Good. So y-intercept is 0. So we put a point right there at 0. The slope is negative 2 or negative 2 over 1. So I go down 2 to the right 1. I'll do that a few more times. And then I'm going to go up 2 to the left 1, up 2 to the left 1, just a few times just to make sure my graph is the way I want it. So it goes to there and goes to there. That looks pretty good, right? Cross right through all those points. It's pretty accurate. All right, let's do this one. Y equals negative 3 halves x plus 1. Well, the y-intercept is 1. It's right here. And the slope is negative 3 over 2. So I could go down 3 over 2, or I could go up 3 to the left 2. Tell you what, let's go up 3 to the left 2. So I start at the y-intercept, positive 1. I go up 3, 1, 2, 3, and across 2, 1, 2. Really, that's all I needed, isn't it? Look how skinny. Let's go down 3. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. All right, that's good enough. Yeah. So that's what it looks like right there. But it worked out really nice because it landed right on that line. When I did my slope up 3 over 2, it landed right here at that point. So I got to find that point. See that point I circled right there? That's my solution. That's my solution for x and y. So what is that point? Well, 2 to the left, so negative 2, and then 1, 2, 3, 4 up. So my solution is negative 2, 4. That's my answer. That's what I want to circle. I got to see the graph, and I got to see where they intersect. Okay? And you write down the point. Let's check to see if it works. Let's put it into the original one. So 2 times x, or 2 times negative 2, which is what? Negative 4, plus y, which is 4. Does that equal 0? Yep, so that one checks. Let's put it into this one right here, our original. You could put it in here if you wanted, but let's put it in the original. So 3 times x, or 3 times negative 2, what's that? It's negative 6. Plus 2 times y, 2 times 4 is 8. Negative 6 plus 8, does that equal 2? Yes, it does. That checks. So good, we got it. And we checked it 100% without a shadow of a doubt. I know I got the right answer. Everybody good? Okay. Let's talk about some other things. It's not really necessarily doing math. It's just words that they use because I think they may ask you. And to tell you the honest truth, I don't really remember seeing these phrases anywhere else, but let's just talk about it. So you have basically three types of systems of equations. 3 types. We'll just put of systems. Is that all right? These names, a little bit wordy, but it should make sense. The 2 that we did already are called independent, consistent. Independent. I don't know if this is like a universal thing or just the author of this book came up with this, because I don't really remember learning these words in other books that I have taught Algebra 2 out of. So what does it mean to be independent and consistent? It just means that you have one solution. And the 2 problems that we've done already, they had one solution because I had 2 lines and they intersect, and they only intersect in how many points? Just 1 point. So there's your one solution. So what do we know is not true about those 2 lines? That they're not parallel to each other, okay? So when they're not parallel to each other and the slopes are not equal, this is what I wrote down. I wrote the slope of one line does not equal the slope of the other line. So as long as they're not parallel to each other, we call them independent consistent, all right? They're going to ask you that in the questions, I believe. Maybe. I can't remember off the top of my head. I'll look when we get closer to the quiz and I'll let you know. But I would write it down anyway. Then we have dependent consistent. This is when you have an infinite number of solutions. Now, what in the world would that look like? Well, it would look like this. Okay, so let's say you had to graph a line and you graphed it like this. Then they give you another line and you graphed it, and it was the same exact graph. See what I did? There's two lines, agreed? There's two lines, and boom, they're right on top of each other. It's kind of hard to see because they're the same color and they're right on top of each other, so you don't see the one behind. But when you have this situation right here, that's called dependent consistent. It's kind of weird. I don't understand why they use these crazy words, but that's what they do. All right? And so that means you have an infinite number of solutions, which means the equations are exactly the same. They may look a little different because you got to divide by something, right? Originally, they might look a little different, but when you write it in y equals mx plus b form, both equations are going to be exactly the same. They're going to have exactly the same slope, and they're going to have exactly the same y-intercepts. Okay? Now you have a third. So you could have two lines that just cross each other. You could have two lines that are exactly the same. What's another situation you could have? I kind of hinted at it a little bit. You could have two lines that are parallel to each other. Very good. All right? So I could have two lines that are parallel to each other. So how many solutions, like this is one equation that you graphed, this is another equation you graphed. How many solutions are there for this? There's none. There are no solutions. Why? Because they never what? They never intersect. They never share the same x and y point. Everybody got that? So they never share. So they call this, these are all consistent. This one is called inconsistent. And no other word in front of it, just inconsistent. And that means that there are, what? No solutions. Now, what's true about the slopes then? Slope of 1 must be what? Equal to the slope of 2, right? So these two slopes are going to be the same. Now, the y-intercepts are going to be different, okay? So the y-intercepts are not going to equal each other, because one is up higher than the other one is. But this would be inconsistent. $25, is that when we get out? Okay, we just barely have enough time to get this little last part in here. So example 4 says classify each system as one of those three. All right, so let's do one really quick. If I got 3x minus y equals -1, and I got 2x plus 3y equals -8. All right, so we got to figure out what they are. So what I'm going to do is I'm just going to put it in slope-intercept form and then look at them, compare them. You don't even have to graph them because you can tell, you know, if they have the same slope, if they don't have the same slope, if they intersect each other, and all that. So all we got to do is put it in slope-intercept form. So I'll tell you what, let's do it like this. Then I can just write underneath of them. That'd be a lot easier. All right, so subtract a 3x from both sides. So -y is equal to -3x minus 1. Multiply everything by a -1, so that's y equals 3x plus 1. Okay, now let's do this one. Subtract a 2x from both sides, so 3y equals -2x minus 8. Divide both sides by 3. Divide that by 3, so y is equal to -2/3 x minus 8/3. Now, what do we know about this? Do they have the same slope? No, so they're not parallel. They're not exactly the same equation, all right? So they're not, you don't have an infinite number of solutions. It's not dependent consistent. So what is this? This would be the first one, which is what? Independent consistent. I'll just shorten it for time's sake. And that's what they're asking you for these. Okay, let's do another one. There we go. 9x minus 3y equals negative 6. And 6x minus 2y equals 4. All right, so what are we going to do again? We're going to solve for y. So let's do that. You could do this a couple ways. I'll do it the old-fashioned way. Negative 3y equals negative 9x minus 6. Divide everything by negative 3. So I get a y equals, that's a positive 3x, and that's a positive 2. All right, let's do this one, and let's compare them after we put them in the slope-intercept form. So the negative 2y is going to stay there. I take the 6x, move it to the other side by subtracting it. Divide both sides by negative 2. And let's see what we get. We get y equals positive 3x, and then this is minus 2. Now we compare them. Do they have anything in common? The slopes, right. They got the same slope. But what about the y-intercepts? They're different. Okay, so they're not the same exact line, are they? But they are lines that one's up here, one's down here. And what do we call this? This would be inconsistent. All right, you get the idea? All right. And then the next one, we don't have enough time, but you do the next one. When you put it in slope-intercept form, both of them will be exactly the same graph. At first, they don't look like they're the same, but then you solve for y, and they both come out to be the same exact graph. And what do we call that? When they're the same, dependent, consistent. Okay? And that is that. So here's your homework. Section 3.1. Come on. There it is. And it's page 110. And you are doing, now this looks like a lot at first, but I put odds. There you go. All right, 9 to 23, just the odds, so you don't have to do the evens. All right, do the problem, check in the back, make sure you got it right, and there you go. Okay, that's it. Good timing.